Hello guys, this is Ivan Christian Belga and I'm going to report the lesson 4, amplitude modulation. So what is modulation? It is the process of altering a characteristic of the carrier in accordance with the instantaneous value of the intelligence signal. It is the modulation of a wave by varying its amplitude, used chiefly as a means of radio broadcasting, in which an audio signal is combined with a carrier wave. The characteristics of the carrier that can be varied are the amplitude, frequency, and phase. The modulation. It is the act of extracting the original information, bearing signal from a modulated carrier wave. It is the counterpart of the modulation on which you are going to extract piece by piece the modulated signal. Meanwhile, the modulation signal is the combination of the signals. So, this is the part on which how a signal is being modulation. This is the information signal on which you wish to be sent or transmitted, and then with the help of the carrier signal, this one, and also with the help of oscillator in which it produces the carrier signal, and then the information signal goes to the modulator, and the output will be an AM signal on which it is the combination of the carrier and information signal, which also have the envelope. These traces is what you call the envelope. Carrier signal. This is a carrier signal that helps the information signal being combined and being modulated. This is the formula of the carrier signal mathematically. EC, where it is an instantaneous carrier amplitude, is equals to peak carrier amplitude times the sine of carrier region frequency and time plus the carrier phase. Or short, EC is equals to EC sine omega CT plus theta. Modulating signal, or what you call the information signal, is the one containing the real information on which you want to share or being transmitted. These two signals, modulating signal and the carrier signal, with the help of modulator, it becomes an AM signal. So, what are the reasons for modulation? Here are some reasons for modulation, and it is the first, for frequency assignment; second, for multiplexing; third, for minimizing interferences; and fourth, for making antenna sizes practical. FCC emission designations, and this is also the code or on which you help to being transmitted. So, list of emission designations for character 1, or the first symbol. The letter indicator here, A, B, C, D, F, G, H, J, K, L, M, N, P, Q, R, S, Q, R, V, W, X. And the details, it's either double sideband, independent sideband, vestigial sideband, and etc. This is the second symbol for the list of emission designator for character 2, or symbol 2. The letter indicator for the second symbol is 0, 1, 2, 3, 7, 8, 9, X. The details are it's 0 for no modulating signal, 1 for one channel containing digital information without the use of modulating subcarriers, 2, one channel containing digital information with the use of modulating subcarrier, 3. One channel containing analog information. 7. More than one channel containing digital information. 8. More than one channel containing analog information. 9. Combination of analog and digital channels. X. Cases not covered by the above. So this is the list of emission designators for character 3 or the third symbol. It is indicated by A, B, C, D, E, F, W, X. A for telegraphy for aural reception. B for telegraphy for automatic reception. C for facsimile or fax. D for data transmission, telemetry or command. E for telephony. F for video television. W any combination of above, and X none of the above. Basically, the first symbol, it is the type of modulation of the main carrier, in which it is either the single sideband, double sideband, double sideband suppressed carrier, or etc. Second symbol signifies the nature of the modulation. Third symbol, type of information being transmitted. So the example of this emission designators is if there is a given code like A3H, in which it means A for double sideband including full carrier, and 3 for one channel containing analog, it means it is a double sideband full carrier containing analog information, and lastly A3C is C for facsimile. It is like a short-term code on which what type of signal it is going on. So amplitude modulation. This is the message signal or the modulating signal which contains information. This is the carrier signal on which it is from the oscillator, the one that carries your signal, and then the combination of this is what you call the amplitude modulating signal. And it is like the shape is almost like the message signal with the help of the carrier signal. It is the simplest way of superimposing the characteristic of the intelligence signal onto a carrier. It is also produced by varying the amplitude of the carrier signal in proportion to the instantaneous amplitude of the intelligence signal. So this is the two requirements for modulating and for modulation, and then this is the outcome, which is what you call the AM signal. The trace of the peaks of an AM wave is what you call the envelope. Let me go back to the other slide. This is what you call the envelope. And going back, it is also have the same shape as the modulating signal, and EAM is equals to A sine omega CT, which is the instantaneous value of the AM signal, and EM is equals to EM sine omega MT. It is the instantaneous value of intelligence signal. This is the breakdown of the signals, of the AM signals, So this is your AM signal here, the blue one. The red one here is the modulating intelligence signals, or what you call the modulating signal. This is the lower sideband, on which the one here. And then the carrier, on which supposed to carry the modulating signal. Yes, that's right. And then the upper sideband, this one. So if you combine all these four, it will result to an AM wave, the time domain. So thank you for listening and watching to my video report. Have a nice day.
Modulation index. Modulation index is the term that describes the amount of amplitude change in an AM waveform. It is also called the coefficient of modulation, modulation factor, or modulation depth. So the percentage of modulation can be calculated by multiplying m to 100%, where m is the modulation index. So m is equal to E sub m over E sub c, where E sub m is the peak voltage of the intelligence signal, E sub c is the peak voltage of the carrier signal. So m can be calculated as Vmax minus Vmin over Vmax plus Vmin, where Vmax is the maximum point in the AM wave and Vmin is the minimum point in the AM wave. There are three classifications according to degree of modulation. First is under modulation, where m is less than 1 and E sub m is less than E sub c. Next is perfect modulation, where m is equals to 1 and E sub m is equal to E sub c. Lastly is overmodulation, where m is greater than 1 and E sub m is greater than E sub c. AM spectrum shows how the bandwidth is calculated, where the bandwidth is the frequency of the upper sideband minus the frequency of the lower sideband, where the frequency of the upper sideband is equal to f sub c plus f sub m, and the frequency of the lower sideband is f sub c minus f sub m. So bandwidth can be calculated as 2fm.
Lesson 4. Amplitude Modulation. This is the formula for unmodulated power. P sub c is equals to V sub c RMS squared over R is also equals to E sub c squared over 2R, where P sub c is unmodulated carrier power, E sub c is peak voltage of the unmodulated carrier, and R is load resistance. This is the formula for lower sideband power and upper sideband power. P sub LSB is equals to P sub USB is equals to B sub LSB RMS squared over R is also equals to P sub C times M squared over 4, where P sub LSB is lower sideband power, P sub USB is upper sideband power, P sub C is unmodulated carrier power, and M is modulation index. This is the formula for total transmitted power. P sub T is equals to P sub C plus P sub LSB plus P sub USB is also equals to P sub C times 1 plus M squared over 2. This is the power spectrum. On the both sides, it is consists of the lower sideband and upper sideband power, while on the center, it is consists of the unmodulated carrier power. This is the formula for the percent power in the carrier. P sub C is equals to P sub C over P sub T is also equals to P sub C over P sub C times 1 plus M squared over 2. While this is the formula for the percent power in the sidebands. P sub SB is equals to P sub SB over PT is also equals to P sub C times M squared over 2 over P sub C times 1 plus M squared over 2. Among the three signals comprising AM, only the sidebands contain the information. The information found in the upper sideband is identical with the lower one. Notice that at 100% modulation, 66.67% of the total power is contained in the carrier and only 33.33% is in the sidebands. Thus, it is wasteful to transmit the carrier and is redundant to transmit both sidebands. This is the formula for peak voltage of the modulated carrier. P sub SB is equals to E sub C times square root of 1 plus M squared over 2, where E sub T is peak voltage of the modulated signal and E sub C is peak voltage of the unmodulated signal. And this is the formula for peak current of the modulated carrier. I sub T is equals to I sub C times 1 plus M squared over 2, where I sub C is peak current of the unmodulated carrier, and I sub T is peak current of the modulated signal.
Hello guys, this is Melvin Mark L. Padilla, and I'll continue discussing lesson 4. So this time it's all about simultaneous modulation. So we have this figure. This appears to be a sine wave. In the left side of the figure, or the sine wave, it is the lower sideband, and the right side is about the upper sideband. So in the center we have the longest line, or the EZ, E sub Z, which is defined here, the peak carrier amplitude. So the different components of the sine waves, of the sidebands rather, are found by these formulas, different formulas. And the component of each formulas are as follows. E sub C, earlier, is the peak carrier amplitude. F sub C is the carrier frequency. M is the modulation index. F sub Mn is the highest modulating frequency. If M sub M3 is greater than Fm sub 2 and greater than Fm sub 1, then when we will get the bandwidth, we will use this formula. The frequency of the upper sideband minus the frequency of the lower sideband. The frequency of the upper sideband can be broken down into this formula, which is the frequency Fc plus F sub Mn. This part of the equation or formula is derived from the frequency of lower sideband. So, simplifying this formula, we will get the bandwidth is equals to the 2 times F sub Mn, where F sub Mn is equals to the highest modulating frequency. So next, the modulation index for simultaneous modulation. When several frequencies simultaneously amplitude modulate a carrier, the combined coefficient of modulation is defined as, by this formula, M sub t equals to the square root of the summation of M sub 1 squared plus M sub 2 squared plus M sub 3 squared plus M to the n squared, where M sub t is the total or effective modulation index, M sub 1 is the modulation index for the first tone, M sub 2 is the modulation index of the second tone, M sub n is the modulation index of the nth tone, meaning you can have many tones you have as you want. So thank you guys for listening. Hope you guys learned